years ago, when a lot of these systems were first built, they used a medium called Fuller's Earth to remove the acid from the fluid. Because Fuller's Earth itself is basically a clay product, some of that clay leaches into the fluid as a particulate. And for that reason, and again, this just goes back to the way of thinking back in the early 60s, a 10 micron cellulose filter element was put downstream of there, and it was called a polishing filter. But that polishing filter's sole purpose was to capture the particulate that the Fuller's Earth actually injected into the system. But they did that because they have to remove acid. If this fluid is left unchecked, like we said earlier, the acid number will get out of control. At that point in time, you have all kinds of system issues. There's another medium called activated alumina that's on the market now. It's a little bit better than Fuller's Earth in some degrees, but in other degrees, if you look at some of the activated aluminas, it'll flat out tell you do not use this in used fluid, but it doesn't define what used fluid is.
I think my assumption would be in service, but you're right, it is a gray area.
It has had situations where it's caused some pretty severe gels to form within phosphate ester fluids and EHC systems. Of course, that leads to filters blinding off, valve sticking. We use a medium called ICB resin for ion charge bonding. It's very similar to the resin that we use to remove oxidation byproducts out of turbine oil for varnish, which, if you think about it, oxidation, and we discussed this in varnish, we can discuss it again now briefly. Oxidation is nothing more than a loss of an electron in the presence of oxygen. You get a polar compound, slightly positive charge. In this particular fluid, most often oxidation always trends towards an acid, which is why we're really concerned with acid number. And we just use a more aggressive resin to remove the acid and other dissolved polar compounds out of this fluid.
Well, I think a couple things are important to point out about that resin. The two that you talked about, the Fuller's Earth and the activated alumina, they're alkaline, so they're trying to neutralize it that way, and they introduce things in that you have to filter out.
Correct.
And one thing that what we're using, it's considered ion exchange. So the term is ion exchange, but I like that we call it ion charge bonding, because when you hear ion exchange, it sounds like you're taking something out and putting something in. You're exchanging it, and you're not. You're literally giving that charged particle something to stick to. So the term's adsorption with a D, but there's nothing going back into the fluid. You don't need a post filter. There's not an exchange. You're just pulling these particles out. And that in itself, I think, is a really big benefit. There's not something going back in that you have to deal with. When you look at these other methodologies, some of the mineral salts, the things that come out, that can leach out, can actually accelerate the oxidation and acid production. So you have these technologies that, if you kept it in a very, very narrow window, worked okay. They would take the acid out. The problem is, if the acid level got too high, then you start leaching these mineral salts out of the product that you had to keep the acid out, which accelerates acid production.
Right.
So a lot of the bad reputation this fluid had was because of the technology that was available to condition it and to maintain it, and people not really paying attention and keeping it in that narrow window. So I think one of the greatest advantages of going to ion exchange or ICB is that you're not worried about something coming out that make things worse. If my job is to clean up your fluid, I'm doing it to make things better.